This is a video walkthrough for practice 6E. Our first question asks us to explain the mistake or mistakes that were made in the solution below, as well as how you would solve the equation correctly. Notice that it's not you're not being asked to find the correct solution. You're just being asked to describe how you would solve. The mistake is actually in the first step, in which the right side of the equation was squared incorrectly. Squaring does not distribute to addition. The square of that right side should be the right side times itself, which we can FOIL to get a result of x minus 8, first term, plus 8 times the square root of x minus 8 for the middle term, which is the combination of the inners and the outers, and then a plus 16 for the last term. In 2 through 21, we're asked to solve and check for any extraneous solutions. So in 2, we have a square root that's equal to 4. We can solve this by squaring both sides. And that gives us a result of 3x plus 1 is equal to 16. Subtracting 1 and dividing by 3, x is equal to 5. And checking that solution by replacing x with 5, we get the square root of 3 times 5 plus 1, which is the square root of 16, and that is equal to 4. So we have a correct solution, so we can accept that one. In 3, we have a very similar equation, so we're going to square both sides and get a result of 3x plus 1 is equal to 16. Seems familiar, and we get that very same solution that we found the last time. But when we check the result, we get the square root of 16 is not equal to negative 4, so that means that this solution is an extraneous one, which means that there is no solution. In 4, since we have a subtraction on the outside of the square root, we're going to need to isolate the square root by adding 2 to both sides first, and then squaring both sides, which will give a result of 2w minus 3 is equal to 9. Adding 3 and dividing by 2 gives us w equals 6. And this solution checks, so that means w equals 6 is a valid solution. In 5, we have a cube root equation, so we need to begin by isolating that radical. The cube root of 4z minus 1 is equal to, and we do that by subtracting 1 from both sides, so that's equal to 3. And then we can cube both sides, which gives us a result of 4z minus 1 is equal to 27. Adding 1 and dividing by 4, we get z equals 7. And this solution checks, which means that z equals 7 is a valid solution. A quick note about cube root equations. It is impossible to produce an extraneous solution when cubing both sides of an equation, so that will not result in any extraneous solution. So if you're confident that you've done the algebra correctly, it is not necessary to check every single solution when cubing both sides of an equation. It is necessary to check when squaring both sides. In 6, we need to begin by subtracting 3 from both sides. 1 minus 3 is negative 2, and so negative 2 is equal to the square root of 5a minus 1. Now let's square both sides, and when squaring both sides, we get 4 is equal to 5a minus 1. Adding 1 and dividing by 5, we get a is equal to 1. This solution does not check, which means that a is equal to 1 is an extraneous solution, and so there is, in fact, no solution for this equation. And so that's a result of squaring both sides. I do want to point out here that in this step, we could have stopped right there and said, oh, that square root should not be equal to a negative number, so no solution is possible. In number 7, we can start by adding 5 to both sides of the equation, and in doing so, negative 3 plus 5 is equal to 2, and then raising both sides to the 4th power to undo the 4th root, So 7m minus 5 is equal to 16. Adding 5, 7m is 21, and m is 3. This solution checks, so m is equal to 3 is a valid solution. I should point out that when we're raising both sides to an even power, it is necessary to check. So even roots, those may result in extraneous solutions when we raise both sides to an even power. In 8, we can begin by raising both sides to the second power, or squaring. 3 times the square root of n times 3 times the square root of n is 9 times the square root of n squared, which is n. And then on the right side, the squaring undoes the radical. So 9n is equal to 7n plus 4, subtracting 7n, and dividing by 2, we get n is equal to 2. And performing the check, this solution checks since 3 times the square root of 2 is equal to the square root of 18, so n equals 2 is a valid solution. In 9, we can begin by squaring both sides of the equation. So u squared is equal to 5u plus 6. This is a quadratic equation, so we're going to want to move all terms to the same side of the equation, so subtract 5u and subtract 6. And then factor. And this factors to u minus 6 times u plus 1. And so either u minus 6 is equal to 0 or u plus 1 is equal to 0. So u is equal to 6 or u is equal to negative 1. The solution of u equals 6 checks, so it's a valid solution. And the solution of u equals negative 1 is an extraneous solution. So the only valid solution is u equals 6. In 10, we can begin by cubing both sides of the radical, or of the equation. So that's going to result in x cubed is equal to x cubed plus x squared minus x minus 12. Subtracting x cubed from both sides, we get 0 is equal to x squared minus x minus 12. The trinomial can be factored into x minus 4 times x plus 3. So either x minus 4 is equal to 0 or x plus 3 is equal to 0. And x is equal to 4 or x is equal to negative 3. The solution x equals 4 checks since 4 is equal to the cube root of 64. And the solution of x equals negative 3 also checks since negative 3 is the cube root of negative 27. So both of these solutions are valid solutions. And I should point out that a cube root equation will not produce extraneous results because we are cubing both sides of the equation or raising it to an odd power. In 11, we can begin by squaring both sides. 3k times itself is 9k squared, and the square root times itself is the content of the radical. So we have a quadratic equation, and I'm going to bring all terms to the same side of the equation. And then we have a quadratic equation where we can factor. The trinomial factors into 3k minus 1 times 3k minus 4. So either 3k minus 1 is equal to 0 or 3k minus 4 is equal to 0, which are, those equations are going to give us two solutions of k is equal to 1/3 or k is equal to 4/3. The solution of 1/3 checks since 1 is equal to the square root of 1. And the solution of 4/3 checks since 4 is equal to the square root of 16. So therefore, both solutions are valid solutions. In 12, we can begin by isolating one of the radicals. It doesn't really matter which one you pick, but I usually like to isolate the bigger radical. So I'm going to isolate square root of x plus 2, and then square both sides. On the left side produces x plus 2. On the right side, we have to think of this as 2 minus the square root of x times 2 minus the square root of x. So Product of the firsts is 4. Product of the outers and inners combined is 4 times the square root of x, and product of the last is plus x. Let's begin by subtracting x from both sides, and then subtracting 4 from both sides, and then dividing by -4, and that'll give us positive 1/2 is equal to the square root of x, which gives us an x value of 1/4 if we square both sides. And this solution checks because 1/2 plus 3/2 is 4/2 or 2. So x equals 1/4 is a valid solution. In 13, we can begin by squaring both sides since the radical is isolated already. And on the right side, we're going to have to square 1 minus y, which means 1 minus y times 1 minus y. So think FOIL method. Product of the first is 1, and then the outers and the inners combine, -2y, and then the last y squared. Now we have a quadratic equation, so one side must be 0. So I'm going to subtract off 4y, which will give us a minus 6y on the right, and subtract off 1, which means that we have no constant term. So we can solve by factoring, and factoring we get y times y minus 6 is equal to 0, which means that either y is equal to 0 or y minus 6 is equal to 0. And so that gives us two solutions, y equals 0 or y equals 6. The solution of y equals 0 checks since the square root of 1 is equal to 1, and the solution y equals 6 does not check since the square root of 25 is not equal to -5. So that means that y equals 6 is an extraneous solution, meaning the only valid solution is y equals 0. In 14, we're going to want to isolate the radical term by subtracting c, and then squaring both sides. 2 times the square root of c times 2 times the square root of c is 4c, and 3 minus c squared is 9 minus 6c plus c squared. Remember, that's 3 minus c times 3 minus c, so we have to FOIL. And then I'm going to bring that 4c to the other side of the equation. First term is c squared. Subtracting 4c, we get minus 10c, and then plus 9. And then factoring, that's c minus 1 times c minus 9. So either c minus 1 is equal to 0, or c minus 9 is equal to 0, which gives us two solutions, either c equals 1 or c equals 9. The solution c equals 1 checks since 1 plus 2 is equal to 3. And the solution of c equals 9 does not check since 9 plus 6 does not equal 3. We can see that sign error that's creeping in there, right? When we have an extraneous solution, it's 9 minus 6 that equals 3. So when we square both sides, sometimes the sign can go awry because squaring a negative and squaring a positive produces the same result. So for this equation, c equals 1 is the only valid solution. In 15, we can begin by isolating one of the radicals, so I'm going to subtract the square root of m from both sides, and then squaring both sides. So on the left side, m plus 7. On the right side, 9 minus 6 times the square root of m plus m. Remember, we are FOILing here, not distributing the square over the subtraction. All right, we can subtract m from both sides of the equation, and then subtract 9. And finally divide by 6, which will give us -2/6, which reduces to 1/3. And then square both sides, and that'll produce a solution of m equal to 1/9. That solution of 1/9 checks since 1/3 plus 8/3 is 9/3, which is 3. So 1/9 is a valid solution. In 16, we have one of the square roots already isolated, so we can begin by squaring both sides. And on the left side, we're going to have to FOIL. So the product of the first is w minus 5, and the inner and outer products are each -4 times the square root of w minus 5. So that adds up to -8 times the square root of w minus 5. And then the last -4 times -4 is 16. And then on the right side, the square root of w plus 3 squared is w plus 3. Let's subtract off our w from both sides and combine some like terms. So we're going to get rid of those w's on both sides by subtracting them off. and then I'm going to combine my like terms here of negative 5 and 16. Don't be tempted to combine the negative 8 because it's multiplying that radical. So we have negative 8 times the square root of w minus 5 plus 16 minus 5, which is plus 11, equals 3. Now we can subtract off 11 from both sides, and that'll get us negative 8. Dividing through by negative 8, the square root of w minus 5 is equal to positive 1. Squaring both sides so that we now have a single radical gives us w minus 5 is equal to 1, and w is equal to 6. This time we have an extraneous solution since 1 minus 4 does not equal positive 3. So that means that w equals 6 is an extraneous solution, and that there is no solution. In 17, we can again begin by squaring both sides. On the left side, we're using the FOIL method because we're multiplying a binomial times itself, or squaring a binomial. So the product of the first terms is the square root of 3x plus 4 times the square root of 3x plus 4, which is 3x plus 4. And the product of the inners and outers are each minus 1 times the square root of 3x plus 4. So combining them, that's minus 2 times the square root of 3x plus 4. The product of the last negative 1 times negative 1 is positive 1. On the right side, the square root squared is 2x plus 1. So I'm going to begin by subtracting off some things. I notice that I have a plus 1 on both sides, so I'm going to subtract that off. And then I'm also going to subtract my 3x off from both sides. So that's going to give me a negative x. And I'm going to subtract my 4 off from both sides, so minus 4. And then that's equal to negative 2 times the square root of 3x plus 4. At this point, we can square both sides, or perhaps if you like this better, we can go ahead and multiply all terms through by negative 1. That may make it easier because we have to deal with less negative signs that way and less room for mistakes. Just change the sign of every single term. All right, now we're going to square both sides. And on the left side, 2 times the square root times 2 times the square root is 4 times the content of the square root, but remember that we still have a grouping symbol there. So 4 times the quantity 3x plus 4. And on the right, x plus 4 squared is x plus 4 times x plus 4, which is x squared plus 8x plus 16. So let's distribute the multiplication over the addition and bring down the right side of the equation. We're going to subtract 16 off from both sides, and we're also going to subtract 12x off from both sides, which gives us x squared minus 4x is equal to 0. That's x times x minus 4 is equal to 0. And so either x is equal to 0 or x minus 4 is equal to 0, which would give us an x equal to 4 solution. The solution x equals 0 checks since 2 minus 1 is equal to 1. And the solution x equals 4 checks since 4 minus 1 is equal to 3. So both solutions are valid. And so 0 and 4 are both acceptable solutions to this equation. In 18, we have an equation with a rational exponent in it, which is essentially a root. So I'm going to add 2 to both sides to give us k to the 5/3 power is equal to 32. And then I'm going to raise both sides to the reciprocal power or to the 3/5 power. And when we raise a power to a power, we multiply exponents. So that gives us k on the left side. And on the right side, it gives us the 5th root of 32 raised to the 3rd power. The 5th root of 32 is 2, and 2 raised to the 3rd power is 8. So the solution k equals 8 checks since 32 minus 2 is equal to 30, so k equals 8 is an acceptable solution. In 19, we can begin by raising both sides to a reciprocal power, and when we raise a power to a power, the exponents multiply, so 2/3 times 3/2 is 1, which gives us a plus 3 on the left side. 9 to the 3/2 is the square root of 9 raised to the 3rd power. So a plus 3 is equal to 3 cubed, which is 27. Now, we have raised both sides to an even root, right? Because we've taken a square root. And something that is important about taking a square root in an equation is that you have a positive or negative value that's possible. So we can also say that a plus 3 is equal to the opposite of the square root of 9 cubed. So that would be negative 27. So subtracting 3, we get 24 or negative 30. We can see that the solution a equals 24 checks since 3 squared is equal to 9. But we can also see that a equals negative 30 checks as well, since negative 3 squared is also 9. As a general rule, it is possible to have both a negative and a positive solution when we have an even exponent in the original equation. So for this equation, negative 30 and 24 are both valid solutions. In 20, we need to subtract 1 first, and then raise both sides to reciprocal powers. So x minus 2 is equal to the cube root of 8 squared. So x minus 2 is equal to 2 squared, which is 4, and so x is equal to 6. A negative solution here would not be valid for x minus 2 because we're raising to an odd power in the original equation, and the solution path is taking a cube root. Our solution checks since 8 plus 1 is equal to 9, so x equals 6 is a valid solution. In 21, we can begin by subtracting 1. And then raising both sides to the reciprocal power, or 5/2 power. Since we're raising to an even root power, or a power with a denominator of 2, that means that we have both a positive and a negative solution to consider here. So y minus 7 could also be equal to negative 4 raised to the 5/2, or the opposite of 4 raised to the 5/2. So y minus 7 is equal to the square root of 4 raised to the 5th power, or y minus 7 is equal to the opposite of the square root of 4 raised to the 5th power. So y minus 7 is 2 raised to the 5th power, 32, or y minus 7 is negative 32. So adding 7, y is 39, or adding 7, y is negative 25. The solution y equals 39 checks, as does the solution negative 25. So negative 25 and 39 are both valid solutions.